This is Mr. Martin. These are the video notes for Geometry Honors Section 3.3. Bunch of information in this video. We're going to be talking about CPCTC, which stands for Corresponding Parts of Congruent Triangles are Congruent. So, based on the definition that we talked about for congruent triangles, once we prove the triangle's congruent, and we're going to use three pieces of information for, we'll either use three pair of sides, we'll use two pair of sides and the included angle, or two angles and the included side. So we're going to use three pieces of information to get the triangles congruent. Once we do that, we know that all the other parts are going to be congruent. So the other three pair of corresponding parts are going to be congruent. So remember, the definition states that if triangles are congruent, their corresponding parts are congruent. So so once we have that the triangle is congruent, so if we know, or if we prove, or if we have already proven that the triangles are congruent, then the corresponding parts are congruent. So this would be something that we use after triangles are congruent. Okay? And if you want to write it out in if-then form, you can, but here again we're going to have another exception to our if-then rule. We can rephrase this as corresponding parts of congruent triangles are congruent, and notice if we take the first letter of each word, we get CPCTC. So keep in mind what those letters stand for so that you don't forget how to say it. Corresponding parts of congruent triangles are congruent, CPCTC. Alright, and again, this important note, make sure that you only use this definition after you prove the triangles are congruent. Okay? Alright, so let's take a look at how we would use this in a proof. Fairly straightforward example to start with. We're given that AB is congruent to DE. Remember, I always like to mark up the picture with tick marks. I think it's worth taking an extra 10 seconds to draw the figures from the book onto your homework. So I've got angle A congruent to angle D, and then I've got AC congruent to DF. So we can see right away from the tick marks that I can get these triangles congruent by side angle side, and then these are going to be corresponding parts. So once I prove that the triangles are congruent, I know that BC is going to be congruent to EF because they're corresponding parts. So let's get the proof down. I've got AB congruent to DE, and I've got angle A congruent to angle D, and I've got AC congruent to DF. So these are all given. And third one given. Okay, and then again, based on the given information, I can prove the triangles are congruent. So step 4, I've got triangle ABC is congruent to triangle DEF by side angle side, and then the steps really, they don't have to be in any particular order. I'll just usually put them in numerical order, but if you want to put them in order to match the two sides and the angles, that's fine. In this case they are. And then now that the triangles are congruent, I know that the other three pair of corresponding parts are also congruent. So I know that BC is going to be congruent to EF, and the reason here is if triangles are congruent, their corresponding parts are congruent, or the abbreviation CPCTC. Okay, really you just have to write this for the notes. I'm just going to put in here, if triangles are congruent, then their corresponding parts are congruent. Okay, so that's really what we're looking at there. So that's our first example. Moving on to circles and two-column proofs. So the property of circles that's really going to be useful for us is that the radii of a circle or radii of congruent circles are congruent. Okay, all radii of a circle are congruent, all radii of congruent circles are congruent. So if segments are radii of the same circle or congruent circles, so pick whichever one is appropriate for the problem. Pick which is appropriate for your problem. Okay, then they are congruent. All right, and once again, we'll have an exception to our if-then rule when we're writing our reasons. When using this property in proofs, we can abbreviate it as radii of the same circle are congruent, or radii of congruent circles are congruent. All right, and if you want to write the if-then form, feel free. You could do that. Just pick the same circle or congruent circles, whichever is appropriate. Okay, so when we use radii in proofs, and this is a little bit different than the book, we're going to do it in 2 steps, kind of like the way we do vertical angles. So when we use vertical angles, we state the vertical angles, and that's assumed from diagram. We're going to do the same thing with radii. State the radii, and that's assumed from diagram. All right, and we know that they're radii because we can look at the picture. And then once we state that they're radii, we can state that they're congruent and use the appropriate reason. All right, so an important note here. Note, if you are given circle A, this indicates that A is the center of the circle. Okay, so circle A, that has an important meaning with it, that A is the center. Alright, so before we get to the example using a circle, we're going to talk about one other concept that we're going to incorporate into the example. Sometimes in a proof you're going to want to use or draw in segments or lines. Okay, and really as long as we have 2 points, I can connect them with a segment or a line. So since any 2 points determine a segment or a line, we are able to do this. So if we take a look at this example here, I've got circle A, so that means that A is the center, and I've got BC congruent to DC. And somehow I need to prove angle 1 congruent to angle 2. So if somehow I can get 1 and 2 to be parts of 2 congruent triangles, then 1 and 2 would be corresponding parts. So if I draw in segments, and notice that I'm making them dashed because they're not really part of the original figure, I can draw those in. And I'm going to put that step into my proof that I drew those in, and we can see that since they go from the center of the circle to the circle, that they're going to be radii, and since they're radii of the same circle, they're going to be congruent. So here's how we're going to do this in the proof. So let's get our given information. We have 1 is given circle A, and then number 2 is BC is congruent to DC, given. And I am going to draw AB and segment AD, and the reason for this is 2 points determine a segment. Okay, so this is our reason that we're going to use. 2 points determine a segment. This is a reason that we're going to use when we draw auxiliary segments or lines. Most of the time it'll be segments. Alright, so now I know that AB and AD are radii, so I'm going to say AB and AD are radii of circle A. Make sure you specify what circle they're the radii of so that we know they're radii of the same circle. And this is assumed from diagram. Assume from diagram AFD. And now that I know that they're radii of the same circle, I know that they're congruent. So AB is congruent to AD. Radii of the same circle are congruent. So I'm going to mark that on my picture here. So if I'm trying to get these two triangles congruent, so far I have a pair of sides over here and I have a pair of sides over here. So I need to either get one more pair of sides or a pair of angles, and I can see that I have this segment that goes down the middle, which is reflexive. So I'm going to use that. So for step 6, I've got that AC is congruent to AC. That's going to be our reflexive property. And that gives me another pair of sides. So now I've got the 3 pair of sides I need for side, side, side. So I can say that my triangles are congruent. So I've got triangle ABC is congruent to triangle ADC. Make sure you name it in a corresponding order. Side, side, side. And the 3 steps that I have my parts from are 2, 5, and 6. And now that the triangles are congruent, I know that angle 1 and 2, since they're corresponding parts, they're parts that match up. Angle 1 is going to be congruent to angle 2. Corresponding parts of congruent triangles are congruent. Okay, so this second example has a lot of important and new stuff for us. We're using radii. So again, we state the radii in step 4, then we can say they're congruent. We're using auxiliary segments in step 3. You're going to just say draw, and then whatever segment or segments you're drawing in, and it's because 2 points determine a segment. And we've got our corresponding parts of congruent triangles are congruent. We've got our CPC/TC. So write down any questions that you have in class, and we'll see you next time.